Good day to the Normal panel of judges. We are Samantha Nicole Montalban, Jaya Daludilya, and Althea Minyat Subuko. Today, we formally present to you our research titled AEROHIVE, Scalable Urban Vertical Bio-Unit for Air Pollutant Reduction, Microclimate Cooling, and Circular Organic Waste Upcycling. This study is rooted in a clear and pressing urban reality. As cities continue to grow, environmental challenges intensify, air pollution increase, urban temperature rise, organic waste accumulates, and accessible green space steadily decline. Recognizing this convergence is what led us to develop AEROHIVE.
To establish the foundation of the study, we begin with the background of the research. AEROHIVE is a plant-based modular bio-unit designed as a single integrated system. It utilizes compost-derived growing media to support high leaf density plants that actively interact with surrounding air. Its vertical and modular design allows deployment in space-limited environments such as courtyards and narrow urban areas where conventionally horizontal greening is not feasible. In addition to its environmental role, AEROHIVE is intentionally designed as an educational platform where making sustainable and circular practices are visible and accessible.
From this background, and with the help of global assessments, the study identifies four interconnected issues. First, persistent exposure to particulate matter and carbon emission continue to pose serious public health risks, as documented by the World Health Organization. Second, the absence of sufficient urban vegetation contributes to intensified heat, with the Intergovernmental Panel on Climate Change linking dense built environment to higher localized temperature. Third, organic waste is widely underutilized despite its potential. Data from Food and Agriculture noting that composting remains underused in some urban waste systems. And finally, current intervention or existing approach address these issues or problems in isolation rather than through an integrated solution. Therefore, the central problem is the absence of a compact, low-maintenance urban system that simultaneously improves air quality, heat reduction, upcycles organic waste while maintaining or remaining educational and replicable.
Guided by these issues, our team worked collaboratively to compare multiple solution pathways. Our collaboration followed a cycle for review, research gathering, and prototype logic validation. We reviewed evidence-based plant systems for air purification and urban cooling, examined urban composting practices, and assessed existing alternatives such as horizontal urban greening, mechanical air filtration, and standalone composting systems. While these approaches showed effectiveness individually, findings from existing studies and real urban site conditions, including the work of Perani and Rosasco in 2013, revealed key limitations, particularly high space requirements, energy dependence, and the lack of integrated functionality and dense urban environments.
We compared solutions using criteria: space efficiency, energy independence, durability, educational visibility, and modular scalability. From this, AEROHIVE was selected as it uniquely integrates pollutant capture, microclimate cooling, waste upcycling, and educational functionality. We propose AEROHIVE as an integrated and modular solution. The system diverts organic waste from disposal and repurposes it into compost-based growing media. Global studies on urban vegetation consistently validate pollutant capture and cooling capacity. Its modular design allows each unit to function independently for reliability, while multiple units can be combined to expand the environmental impact across larger urban areas. This configuration aligns with the findings of Perani and Rosasco in 2013, who emphasized that modular vertical greening systems are particularly effective in dense urban environments where space is limited. This system is also designed for deployment in schools and public spaces, providing both measurable environmental benefits and hands-on sustainability education.
The system assumes access to basic sunlight, routine monitoring, and a consistent source of organic waste condition commonly present in schools and urban communities. But identified implementation risks include plant mortality, environmental variability, and inconsistent waste input. But these risks are mitigated through modular unit independence and nursery preparation of seedlings to increase the survival rates, and then the selection of durable weather-resistant materials. With the execution being established, we now present the AEROHIVE model. This figure shows the final structure of AEROHIVE.
To better understand how the system operates, we now break down the parts of the AEROHIVE and their function. First is the recycled high-density plastic-based platform. It provides stability, moisture-resistant, and load distribution. It's non-porous, so it doesn't absorb water, eliminating rot and mold, which are common cause of structural collapse in human systems. Next is the recycled plastic planting chambers that form the vertical force of the system, which hold the compost-based growing media and support dense vegetation. Last but not the least is the galvanized steel or aluminum frame, which supports the system, offering strength and corrosion resistance suitable for outdoor use.
With the structure defined, this slide explains the AEROHIVE process. The process begins with organic waste being composted and seedlings being prepared in a simple nursery to ensure stronger root development. In parallel, the AEROHIVE structure is being assembled, starting from the base, followed by the vertical steel frame, and then the planting chambers. Once the compost matures and the seedlings are carefully transferred into the compost-filled chambers, it allows immediate nutrient uptake and stable growth within the structure.
To evaluate performance, the study follows an applied pilot design, observation, comparisons before and after installation. The system is designed to operate under normal outdoor conditions without mechanical support, ensuring resilience, low maintenance, and practical feasibility. Monitoring is conducted over 3 to 6 months and includes air quality indicators such as particulate matter, ambient temperature changes, plant growth performance, and the amount of organic waste converted into compost. And the purpose is to evaluate environmental functionality, practical feasibility, and educational value of the AEROHIVE system. Through photosynthesis, AEROHIVE supports carbon dioxide uptake and oxygen release. By utilizing composted organic waste, it closes the resource loop and supports long-term sustainability. Collectively, these outcomes align with key sustainable development goals, including good health and well-being, sustainable cities and communities, responsible consumption and production, and climate action.
Overall, AEROHIVE demonstrates a practical, scalable, and nature-based system that integrates urban greening, organic waste upcycling, and environmental education using established biological processes and accessible construction methods. Now, for the major references, AEROHIVE's scientific foundation is supported by global research from organizations such as the World Health Organization, Intergovernmental Panel on Climate Change, Food and Agriculture Organization of the UN, and then the UN Habitat. Now, this annex, which anchors the study and technical clarity, it consolidates the finalized AEROHIVE structure, its modular frame, vertically stacked planting chambers, compost-based growing media, and the integrated drainage system, demonstrating that the concept is not just theoretical, but fully buildable, functional, and grounded in real-life urban conditions.
From concept to structure, AEROHIVE demonstrates how nature, when guided by design, can drive meaningful change in urban environments.
AEROHIVE is not merely a system placed in the city, it is a system that works with the city.
Proving that sustainable change can begin at a human scale and grow upward.
Thank you for your time and for the opportunity to present our work.